So let's quickly take a look at okay. So let's take a look at the correction to the last assignment. Um, question, the first question. Right? Okay. So let's take it from the first question. Uh, Let me share my screen again. Okay. So for the question number one, we have this question: find the value of x. So from the theorem that we looked at earlier, so the theorem says that the angle at the center is twice the one at the circumference. That's the summary of that particular theorem. The angle at the center is twice the one at the circumference. So what is at the center now? We have 84 at the center. We write that 84 is equal to twice that at the circumference. What is that circumference? That's x. So it means 84 equals to 12. If you divide both sides by 2, we have 84 divided by 2 equals 12. And as a result, x equals to 42. So that's the answer to that particular question. 42 is the answer. The second question, I hope it's clear. So just anytime you can see that both the center and the circumference are coming from A and B. So just put center twice times the circumference. And that's the solution. Question number two. The same thing here. If you look at this, you realize that we have an angle at the center, we have another one at the circumference. And both of them, the lines are coming from A and B. So it means the theorem also works here. And then what we just need to do is that the angle at the center is twice the circumference. You ask yourself which one is at the center. Definitely it is y. So y center equals to twice, two times circumference. Circumference is 35. It means y equals to 7. So that's the solution to that particular question. 7. So the answer is 7. Okay. So the next one, this is theorem about cyclic quadrilateral. You can see four-sided figure in a circle. So what do we do? We have said, so they want us to find the value of 2x minus y. The question is not actually direct. It's not saying we find value of x or y, but 2x minus y. So it means we need to get the value of x and y first. So how do we go about that? From the theorem, opposite angles are supplementary. So it means x plus 85 will give us what 180. X equals to 180 degrees minus 85. And that should give us 95 degrees. So apart from that, we also do the second one. We also realize that y and 110 are opposite. So they are supplementary. So equals to 180 degrees. And y equals to 180 minus 110. And you can see that y equals to 70. So that is that. But the question says 2x, 2x minus y means 2 multiplied by 95 minus 70. 2 times 95, 95, that will be 190 minus 7. And that will give us 120. So the answer is 120. So that's solution to that particular one. Question number 4, quickly. Here, say in the diagram, BZ, BZ, this is BZ, is equal to side YZ, and that's why they have put this sign there. They are equal. Then they said if ZBY, angle ZBY equals to 52, find the value of angle WYZ. 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 So that's the one mark. So what we just need to do, this one does not actually make sense until we form a triangle, and we can see it here, form a triangle. So it means base angle of that triangle must be equal. So the base angle here is 52, it must be equal to the whole of y. It means everything here is what? 52. But it is not everything that we are looking for, it is this part that we are looking for. So everything there is. Now, from what you can see that this particular one, if you are not careful, you see the diagram as being too complicated. Now, what you just need to do is, having got that, do we have any other thing that this 52 can be related to? You can see that this 52 is same as 52 here, which is isosceles, a base angle of an isosceles triangle. Now, you can also look in another direction. Can this 52 also be related to anything? And we have said it that anytime we are dealing with surface geometry this kind, without tangent, we should be thinking of, do we have a center? If you have a center, we should be thinking of angle at the center is twice the circumference, or should be thinking of angle at the semicircle is the right angle. If you don't have a center at all, then you should be thinking towards slightly quadrilateral, or you should be thinking towards what? Angle in the same segment. So in this case now, there's no center. So our thinking should be towards slightly quadrilateral or angle in the same segment. Same segment. Now, if you look at the 52, where is it coming from? This is coming from point Y. And the lines that form 52, they are coming from point Y and point Z. So do we have any other one coming from such? You realize that this is also because it is coming from the lines are coming from Y and Z. So this is also. So having got that as then from there, the next thing is we need to look at any other thing. This 20 can we also use it for another thing. So basically, we are looking for this particular angle. Yeah, we are looking for this particular angle. Yeah. So okay, this 52 might not even be necessary. Yeah. So but let's just look at it. We have been able to get this one as 52. Let's see. It may be useful for us. It may not be useful for us. But I think I've seen another approach. Another approach here is this 20. Yeah, this 20 can be useful. You can see this 20 makes the triangle. Part of the triangle that is made is that this triangle XBZ, triangle XBZ. Yeah, triangle XBZ. So let's see. Now, if you have XBZ, still talking about the same angle in the same segment that we used to get. Do you know that if you pick triangle XBZ, we have three angles there. This angle 20, we also have this angle there, and we also have this angle there. Now, if you look at this particular angle, you realize that it's from what? It's from the two lines are from B and W. If you look at the small one here, the small one here, they are from B and W. So if you know this small one, which is something as this, you can just remove it from 52 to get this one because 52 is the whole of this, and we are looking for this one. So once you get this small one, you can just remove it from 52 to get the remaining one. I want to believe that you understand my message. Let me just clean this thing and explain again. Um, what I'm trying to say is that okay, now this is what they have asked us to find. So there we can just okay, yeah. So once again, since we realize that the whole of this is based on angle, base angle of an isosceles triangle, we are saying that if you can get the small one, which is same thing as this angle here, because we are all from B and W, if you can get that, we just remove it from the whole of it to get the small one. So now let's go. Now if you call this one A plus B plus here, we form triangle. Exactly. So you can do that. Since this one is 52, you can find this small one. Exactly. Find this one, which is 128. Then once you get 120, 128 plus 20 plus 8, you give us 180. But I won't do it like that because there's another theorem that says that this is an exterior angle. Hmm? Exterior angle is equal to the sum of the two opposite interior, or the external angle of the triangle is equal to the sum of the opposite interior. So this is external angle of the triangle. This is the interior of the external. The remaining two angles are 20 and 8. So 20 and 8 are opposite interior. It must be equal to, so from here, 8 is equal to 52 minus 20. That's 32. So angle A is 32. So it means this small one is also the same thing as 8, which is 32. That clear? So this small one is also 32. Now this one that we are looking for angle B that we are actually looking for. You know, A and B make up. So to get your B, in that case, you can just say 52 minus B A. So our B is equal to 52 minus 32, which is equal to 20. So it means the answer to that is what? 20 degrees. So let me explain again. What we have just done here is that we the major thing that we can use, the major one that will give us the straight answer is to look at two major theorems that we are going to. So the first thing is that this angle of an isosceles triangle, because this is the isosceles triangle, so the whole of this, so this is this angle of isosceles triangle. Then consider this triangle X, B, Z. So this angle here, we call it A, is still the same thing as the small angle here because they are coming from the same place. The two lines that form them are coming from the same segment. So they are angle in the same segment. So once we are able to get this A, we can just remove it from 52 to get this particular angle. So that's what we have just done. So to get this A, you can just add 20 plus A must give us 52. If you are not so confident about that, but that's the particular theorem that says that external angle is equal to the two opposite interior. So you can take your time to find this place. Once you get this place from that, get your A, you get 32, then remove it from 52 to give us 20. So that's the answer to that particular one. So the next one, we want us to find the value of PTR. PTR. This is the whole of PTR. So how do we get that from here? PTR. Now, if you look at this, so luckily you can see that we have center there. We have center. So this is the center. So we dig in the line of which this is the center. Can we have the circumference? So we have the circumference there. Let's see. So we can have the circumference. Yeah. So if this is the center, you may not even think of, there are so many things that we can do. You know, we have said if you have the center, then you should be talking towards semicircle or angle at the center is twice circumference. So those two, you can be thinking in that line. Now, if you look at what we have here, semicircle, yes, we can get the semicircle here. If this is the diameter now, this is the diameter, so we also have the diameter here. So it means we can actually usually get angle in the semicircle. So if you trace this one up, trace this one to up, we have as 90. So if that is 90 degrees, we are looking for this angle. Luckily, we can just try to see how we can manipulate this triangle here that have that angle 90 degrees. Yeah, if you manipulate that, we just need to get it. And if you look at this arc, where it's coming from P and C. That's the same place that 33 is coming from 33. So you see that 33, you can actually what bring this 33. If you bring this Q, you see that it's switching into half directly. So it means this angle just what 33. So if you call this angle A, then you can actually say that A plus 90 plus 33 equals to 1. A equals to 180 minus 123. That would be 7. That's the value of A. So that's the solution to that one. So A is 7. That's the answer to that. So let's go to the next question, number 6. Okay, see the same, but you want us to get PRS in this case. PRS. PRS. So that's the whole of PRS. You want to get PRS. So don't forget for what we have done the other time, we got this to be 33. This is 90, and we later got this to be 7 from what we have done so far. Now, you want us to get the whole of the so it means we mix this. Actually, in the first place, when you see the diagram, you'll be hearing, but you just need to break it down and analyze it based on what you have done. So, and that is just what you need. Now, if you need to analyze what we hear to now, we have got this part. We have got this part. So, we just need this part. And if you look at this part, where is the angle coming from? The two lines that form the angle, they are coming from here and here, which is the same place that this 76 is coming from. It is just that 76 here is the angle at the center. Why we can say that this one is angle at the circumference. So if you label it X, for example, so what do you do? Center 76 equals to 2 times circumference, 2 times X. So it means 2x equals to 76. So X will be equal to 76 over 2, which is 30. So this is 30. But we are now looking for everything. So that would be 33 plus 33. And that is what? That's 71. 71. That's the answer to that. So what we just to develop, add to what we have done before, we discover that this one is algo and circumference is the center. So that's that. Then this, you want us to find the value of x. Now, if you look at this one carefully, clearly, you see that it is also this is center. So anytime we have center, we should be thinking in the line of angle in a semicircle or angle at the center is twice circumference. So in this case now, you can see that it's not a semicircle because there's no diameter there. So if you talk about this particular angle, for example, x, you can just develop to realize that this is the angle is related to this x angle at the center is twice this. So it means the one at the center here is twice 100 here. Exactly. So, but it's just that we call this one a major segment. That's why the angle is large. So why this one is minor. The one for this arc is a minor arc. It produces x at the center and it's going to produce 2x at the circumference. That's the exact percent. So whereas this one produces 100 at the center, at the circumference, it's going to produce 200, 2 times 100, 200 at the center. So you can just pick it that 200 plus x is make up angle at the center, angle at the point. So you can just pick 200 plus x equals to x equals to 1. Alternatively, since we have created this particular angle, you this line. So you realize that this angle here and the one here, yeah, you can see this is a cyclic quadrilateral. So you can say that 100 plus 2x is also equal to 100 plus 2x. You can see, yeah, sorry, that's not 2x. Thank you. This is not 2x. This is angle at the center. It's 2 times this. By the time you convert, you realize this one will be x over 2. Yeah, x over 2. This is x over 2. So angle at the center is 2 multiplied by x over 2. So that would be x. So this is x over 2. So another way you can also do it is just to add, since 100 and x over 2 are opposite angles of the cycle quadrilateral, you can just put that 100 plus x over 2 is also equal to 180. So you can use this alternative method. So in this case, we realize that x over 2 is equal to 8 and x is equal to 1. So whichever method you use for both, whichever method you use to solve that particular question, either of the two methods are correct. So either any one of the two is correct. So that is what you can try to do. Okay, so let's go to the next question. So the answer to x is 160. So let me just explain it again. This one is circumference here. This is center. X cannot be center. Mm? It will be facing the same arc with the center. So this 100 is facing this arc. So the center will also be facing that. That's 200. And once this one is 200, you can just add 200 and x to give us 160. So that's the next question. Look at this. So we have center there. Anytime we have center, to be thinking in the line of semicircle or center is twice circumference. So luckily here they have diameter. So if you look at this, the diameter, these are the ends of the diameter. So if they produce line from there, this line will come to C, this one will come to C, it means the whole of line. But now that's not the only thing we are looking for. We are looking for this extra one here. How do we do that? So, but firstly, we have been able to get this one as line. Now we also go again. Let's see what other thing can we do. If you also look at the diagram clearly, you realize that it's a cyclic quadrilateral, a four-sided figure in the circle. Yeah. So can we pick opposite angle there? Yes. 64 and T. Okay, you can get the value of T. So if you call that angle X, for example, so you can say X plus 4 equals to 180. X equals to 116. So that is 116 degrees. Then they also mentioned this, that DCD is equal to AD, meaning they are this is the angle here. Okay, okay. So meaning that in such a case, okay. So in such a case, we can see that we have a base angle and series angle equal. So this is the base angle, this is the base angle. Call it A, call it A. So x plus A will give us, so x plus so in this case we realize that x plus A will give us 180. Sum of angle in a triangle. Our s is 116 plus 2A equals to 180. So you can see that 2A will be equal to 1 and A will be equal to 8. So if A is 32, we need it to add up to 90 to give us the whole of angle BCD that we are looking for. So hence you can say that angle BCD, our angle BCD is equal to 90 plus A, and that will give us 120. So that's the solution to that particular. And the last two questions that we have said, find the length of a chord of a circle of radius 17 centimeter from the center of the circle. Okay, whose distance from the center of the circle is 8 centimeter. Now, from that one, that's one of the facts that we presented the other time. That if you have we have a, say find the length of the chord. Let's assume that this is the chord. We are looking for the length of the chord, and the radius is 17. So let's put it as radius 17 centimeter. Whose distance from the center of the circle is 8 centimeter. So we want to find the length of the chord. Since they have said this line bisected, so from a Pythagorean theorem, you can get the value of x. Whatever we get here will also be the same value as. So using Pythagorean theorem, it means we have 17 squared equals to x squared plus 8 squared. 17 squared is what? 289 minus 64 equals to x squared. So in that case, we have 225 equals to x squared. So our x is equal to 2. Define the square. So if x is 15, this side 2 is 15. So the length of our chord is 2 times x. That's 2 times 2. So the answer is 30 centimeters. And likewise, the last one, the chord of length 24 centimeters. The length of the chord has been given as 24 centimeters, and it's 5 centimeters from the center. So if this is the center, it's 5 centimeters from the center. And you find the radius. So you can just bring out the triangle. So if you bring out the triangle, so bringing out that triangle, sorry about that. So if you bring out that triangle, we realize that we are going to have something of this nature. We're having something of this nature. The 24 centimeter, we divide it into two. So we have 12 centimeter here, and we have 5 centimeter here. So based on that, we can now find this particular side, the radius. So how do we get the radius from there? So that is what we also need to uh, look at. Now, getting the radius, okay? So if you need to get the radius here, um, the radius, we just have Pythagoras theorem. Half square equals to 5 square plus 12 square. So if you do it well, you have to put as the radius. So the radius for that one is 13 centimeters. And that is uh, the assignment. So I'll just go through it several times to get it well. So I wish you best of luck. Thank you very much. So we will meet next time in the class. Uh,